Before we dive into anything further, let's take a moment to discuss the importance of data. Right? Data is crucial in Lean Six Sigma as it provides the foundation for decision making and process improvement. It helps identify areas of waste, track performance metrics, and measure the impact of process changes. Without reliable data, it's challenging to understand the current state of processes or determine the effectiveness of improvement efforts. Therefore, collecting, analyzing, and using data effectively is essential in Lean Six Sigma to drive meaningful and sustainable improvements. In Lean Six Sigma, there's two types of data that are fundamental, and I want you to take into consideration. Right? You have qualitative. Qualitative data is describing and is subjective. It includes observations, opinions, and feedback from stakeholders. Qualitative data provides insights into the human aspect of processes such as customer satisfaction, employee engagement, and organizational culture. Qualitative data is a value for understanding the context and impact of process improvement. Both qualitative and qualitative are essential in Lean Six Sigma for gaining a comprehensive understanding of processes, identifying opportunities for improvement, and making informed decisions. Combining both types of data allow for more holistic approaches to process improvement, ensuring that improvements are not only effective but also sustainable in the long run. In a key concept, we have qualitative. This is going to be colors, objective surveys, customer satisfaction, and quantitative is going to be those number calculations. Now, over time, qualitative can turn into quantitative data, and I'll get into that further. Qualitative data will essentially be the color of items, descriptive factors, maybe some surveys, questionnaires, getting feedback that's not, a percentage-wise number or a calculated value. Now, for quantitative data, I want you to take in consideration this, right? You have two types of data in quantitative analysis, is continuous and discrete. When I think of continuous, these are items that can be measured on a continuous scale. Length, weight, circumference of an apple. Time can be measured on a continuous scale. And also the number of gas that can go into a gas tank, right? The number of gallons there. Discrete would be data that can be counted. I can count the number of cows in this picture. I can count the number of children. And essentially, the descriptions here, there's two I want you to take a look at. Continuous, here's some examples. You have wind speed. You also have water temperature. Discrete, you have eggs in the basket and the number of votes in an election. Is any of you crazy rascals here? The biggest factor here I want you to take into consideration is qualitative and quantitative analysis. We can use both of this data to get a holistic approach on our operation. Now I want to look at some characteristics of data, right? There's three that I want you to kind of grain in your memory, right, is shape, center, spread. Shape's going to refer to the overall appearance of data distribution. Common shapes include symmetrical items such as bell shape or normal distributions. Skewed, one tail is longer than the other, or uniformed, where all values are equally likely. Center is going to refer to the midpoint or average of the data distribution. This is often represented by the mean, median, or mode of the data. And you have spread, which refers to the variability or dispersion of data points around the center. Common measures of spread include the range, standard deviation, and other information that can be both qualitative and quantitative. Analyzing shape, center, spread of a distribution helps practitioners understand the nature of the data and make informed decisions about process improvement and variability reduction. But how is data formed, right? Essentially, when we look at data, how do we collect it? In the DMAIC framework, we look at building off of the interconnectedness of the DMAIC system. Essentially each phase builds upon the previous one as discussed, and that leads us to the measurement phase. During the measurement phase, it's where we're going to create those metrics during the define phase to gather data and track metrics, right? When we track metrics, one thing I want you to take into account here is the data collection, gathering data to understand the current performance of the process. Process mapping is where we're creating detailed maps of the process to identify potential areas for improvement. We're then creating a baseline performance, establishing metrics and benchmarks to measure current process capability. We're also using those statistical analysis and using statistical tools to analyze data and identify variations within the process.